Okay? Somebody read those directions aloud to me, please. Okay, Ollie, as loud as you can.
For each pair of elements below, draw an atomic diagram showing electrons in different energy levels. Draw arrows to show where the outer electrons will go during a chemical reaction, then draw the resulting compound. Finally, fill in the table below each reaction. Refer to sample shown.
Okay, good. So we've got several different steps, very good, that we need to follow today, don't we? Okay, what is the first step that we need to follow today? The very first thing that we are going to do, Seth?
Identify the atoms.
Yes, we will need to know what atoms we're drawing, and that's a good point, because if you see here, each equation will tell us what atoms we're going to be looking at. Okay? So in our directions, what is the next step? What is the first thing after we've identified our atoms? What is the first step? Bethany?
We can draw an atomic structure.
We're going to draw an atomic structure, and today we're going to be using Bohr diagrams. So I'm going to underline the first step. Okay? We're going to draw an atomic diagram, and it's going to be a Bohr diagram. What is our next step, Miss Hudson?
Draw arrows to show where the outer electrons go in a chemical reaction.
Good. We're going to draw arrows to show the transfer of electrons. You can sit down if you want to. All right. Whatever's comfortable. And then third. What's going to be third? We're going to draw a Bohr diagram, then we're going to draw arrows showing a transfer of electrons, then what? Madeline.
Draw the resulting compound.
Okay. Draw the resulting compound. If we had room, we would. If you'll notice in the example, I have the resulting compound drawn. It's not really necessary for today's learning, so we're going to cross that out. We won't be drawing the resulting compound. And then lastly, what will we do? Sam.
Fill in the table below each reaction.
Good. We're going to fill in the table below with the information that it asks for, which in this case are the atoms, valence electrons, electron transfer, and the ion formed. Now, I want to go over with you what that looks like, and I've given you an example. Okay? Here I have drawn, I'm looking at the chemical equation, lithium plus fluorine yields lithium and fluorine. However, together here, they are forming a compound, they have bonded. So, I'm going to start by drawing my Bohr diagrams, and I've done that electronically here. My electrons are not placed in the correct spots because it was difficult to do. But in a Bohr diagram, am I drawing all electrons or just valence electrons? All of the electrons. So lithium has an atomic number of 3. I have drawn 1, 2, 3 electrons. Fluorine, which is my other element, has how many electrons total?
18. I mean, 9.
Not just valence electrons, electrons total. 9. Its atomic number is 9. So I've drawn 2 on my first energy level and 1, 2, 3, 4, 5, 6, 7 on my valence energy level, or my valence shell. Now, knowing what we know from discussing all week ionic bonds, this is a metal or a nonmetal. Lithium is a metal or a nonmetal? It's a what? Metal. Okay, it's a metal. How do we know that? Raise your hand and tell me, how do we know lithium is a metal? Maddie.
It's in group 1.
Okay, it's in group 1. What do we know group 1 to be?
All metals.
Metals. Any particular type?
They're reactive.
They are very reactive, and they have a name. What is that name, Miss Jenna?
Alkali metals.
Good, alkali metals. So there's several different ways we can learn that lithium is a metal. It's in group 1. Some people have said it's in the blue part on my periodic table, and the blue part has a key, and it tells me that it's metal. Okay, several different ways. Lithium is a metal. Metals have fewer electrons. Notice they are in groups 1 and 2, meaning they have 1 or 2 valence electrons. So are they going to be more likely to gain electrons or lose electrons in a bond? Okay, to have a full outer energy level, it's going to be easier for metals to lose electrons. Now, we know that ionic bonds are formed between metals and nonmetals. So nonmetals that are in your groups 16, 17, they're going to have close to full valence shells with 6 electrons, 7 electrons. They're almost full. Are they going to give away or receive electrons? They are more likely to receive electrons. Okay? So metals need to lose electrons. Nonmetals need to receive electrons. So that's why they're a good match. That's why ionic bonds are formed between metals and nonmetals. Okay? So I've shown this transfer here of our valence electron over to fluorine. So now lithium has a first energy level full with 2, and fluorine, once electron is transferred, has a full energy level of 8. So this is how we're going to be drawing today. Now, for the chart, I've given you another example. Doing okay, Sal?
Yeah.
Good. All right. The atoms, we're just going to list the chemical symbol. So in this case, I've listed lithium and fluorine. Then next to that, I've listed their valence electrons. Lithium has 1, and as we saw, fluorine has 7. Now, when I say electron transfer from or to each atom, I'm looking for you to tell me, were there electrons that were lost or electrons that were gained? In this example, we saw that lithium loses 1 electron, and fluorine gains that 1 electron. So that's what we write down for electron transfer. And then lastly, in our last column, we'll be writing ions formed, which is just the chemical symbol and the oxidation number. So let's remember about oxidation numbers. If lithium loses a negative piece, a negative electron, what then is its oxidation number? Sydney? Plus 1. We're going to write it 1 positive. Okay? So you can see there, the ions formed, it's written 1 positive. And for fluorine, which gained that negative piece, its oxidation number is 1 negative. So let's do the first one together. Whoops. It moves backwards on me. There we go. So what's the first thing I need to do? I'm going to look at my equation. I'm determining that I've got lithium and chlorine. What should I do first? Please don't work ahead. You're working along with me. Draw a board diagram of each atom. Okay, so let's start with lithium. I'm going to draw the symbol. How many shells should I draw for lithium? 2. How do you know that? Good. It's in period 2, which indicates how many shells we will draw. 1. Oh, yeah. You might want to save yourself some space. Sometimes these can get tricky. You want enough space between your rings so that you can tell your electrons apart. If your rings are too close together, it's going to start to get messy. And then I'm going to draw chlorine. I know I haven't drawn electrons yet. Chlorine is in which period?
What?
Chlorine is in which period? 3. So I'll be drawing 3 electron shells. 1, 2, 3. Whoa, that one got big. All right, now I can draw my electrons. Lithium has a total of how many electrons? 3. Its atomic number is 3. It'll be important here to draw them in the correct spot. Okay. And chlorine has how many electrons? 17. Here we go. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That one's full. 11, 12, 13, 14, 15, 16, 17. Yes, eventually we will just draw Lewis dot diagrams, but for today we're doing Bohr. So we've got a lot of dots to draw. Now, lithium, metal or non-metal? It is a metal. So is it going to gain or lose electrons? It's going to lose. Chlorine, metal or non-metal? Non-metal. Is it going to lose or gain?
Gain.
Good. So we're going to draw our valence electron traveling from lithium to fulfill its rightful spot on the chlorine atom. We're not actually going to draw it on chlorine. We're just going to show where it goes. And in giving away this negative electron, what charge does my atom take on? It gave away a negative piece. It became positive. Good. Positive by how many electrons? 1 positive. That's how we write our oxidation number. Chlorine, on the other hand, gained a negative subatomic particle, making its overall charge what? Negative by how many? 1 negative. Now, 1 minus 1 is what? 0. So this compound becomes neutral. As these ions join together, the resulting compound is neutral. So before you go to lunch, let's fill in our chart. Our atoms were lithium and chlorine. Lithium had 1 valence electron. Chlorine had how many? 7. In terms of electron transfer, what happened with lithium, JJL?
Lost 1 electron.
Right, it loses 1. And how about chlorine? What happened there, Anna? Good, it gained 1. And in terms of the ions formed, we're writing the chemical symbol with the oxidation number. So for lithium, we're drawing the chemical symbol, and the oxidation number was what, Presley? 1 positive. And for chlorine, it was 1 negative. Excuse me, I've not dismissed you. We will do 2 more together when you come back from lunch. Please don't forget everything you've learned. All right. So calcium and oxygen. Oh, one thing we didn't do with number 1. We are going to try to name them. And the naming technique with ionic bonds, you change the ion that is negative, in other words, your anion. You change the last part of that word to IDE. So anybody want to give a stab? Number 1, we've got lithium and chlorine. Do you know what we call this ionic compound? What do you think, Emerson?
Is it lithium chloride?
Yes, it is. It is lithium chloride. So we are going to attempt to name our ionic compounds as well. Lithium chloride. Okay, good. All right, now on to number 2. We've got calcium and we've got oxygen. Okay, so what do I need to do first? Again, please don't work ahead. Not until we've finished all 3 of the first ones together. What do I do first, Sydney? Draw the Bohr model of the atoms. Okay? So calcium, I can find it in which group?
2.
Good, 2. I meant which period? Good listening.
4.
In period 4, so how many electron shells will I draw? 4. It's a lot. Hard to fit in there. And oxygen. How many shells for oxygen?
2.
So in period 2, we will draw 2. All right. In drawing our electrons, how many electrons does calcium have? 20 total electrons. So let's start. I drew mine awfully close together. I'm going to start with 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That one is full. I'm going to go to the 3rd energy level. 11, 12, 13, 14, 15, 16, 17, 18. That one is now full. In terms of knowing whether the 3rd electron shell will hold 8 or 18, the lower atomic numbers are going to hold 8. It's when you start getting up into the higher numbers, atomic numbers of 80, 90, 100, that 3rd electron shell is going to require holding more. But with the elements we'll be dealing with, we can fulfill our 3rd electron level with 8. All right? So I still need how many more? I've got 18. I need how many more? 2. So my valence shell will hold 2. Now how many do I need for oxygen? Good. I need 8. 1, 2, 3, 4, 5, 5, 6, 7, 8. All right. Calcium, is it a metal or a nonmetal? Let me hear you say it. It's a metal. Is it going to gain or lose electrons? Good. Oxygen, metal or nonmetal? Good. Is it going to gain or lose electrons? Good. So let's draw those arrows. This electron up top I'm going to bring right down over here. And the electron from the side of calcium I'm going to put at the bottom. Okay, just to show where they're going. You with me? Do I need to slow down? Okay. So oxidation numbers. Let's write our oxidation numbers over here. Calcium has lost 2 negative electrons. What will its oxidation number be, Brooke?
+2.
Okay. Or 2 positive. Let's write the number first. And then oxygen. Jake, what do you think? What's the oxidation number going to be?
2 negative.
Good. 2 negative. All right. So let's fill in our chart. We have calcium atom and an oxygen atom. Calcium has how many valence electrons? Good. 2. Oxygen? 6. In terms of our electron transfer, Kayla, how about calcium?
It loses 2.
Loses 2. And oxygen, Drew?
Or gains 2.
Good. Gains 2. Okay. And last part of our chart, we're going to put our chemical symbol with the oxidation number, our ions formed. We have calcium with an oxidation number of 2 positive and oxygen with an oxidation number of 2 negative. Do those cancel out? Yes, to form a compound CaO. Anybody want to give a stab at what we name the ionic compound of Ca and O? Dalton.
Calcium oxide.
Good. Calcium oxide. Okay. We're going to do one more together because it's a little bit different, but I feel like if we've done the first 3 together, then you'll be okay to start on your own. So this next one is just slightly different. What do you notice that's different about this chemical equation? Presley?
It has a 2.
Has a 2 by the fluorine. What does that tell us? What does that subscript of 2 tell us? Ollie? We have 2 fluorine atoms. So you already know if that's your compound that that's what you're going to need to draw. So let's draw beryllium first. Is beryllium our metal or our nonmetal? Metal. Good. Period. 2. 1, 2. Good. Now I've got 2 fluorine atoms. I'm going to draw one here. It's also in period 2 with 2 shells. And I'll draw another one over here just to give myself some space. 1, 2. Right, now I can add my electrons. Beryllium has a total of how many, Jenna?
4.
4, good. Fluorine has how many total atoms, Kaz?
9.
9, good. 1, 2, 3, 4, 5, 6, 7, 8, and 9, but I have 2 of them, so I have to do it on the other one as well. Okay, so I have a beryllium with 4 and 2 fluorine, each with 9. Now, so this one's a little bit different. Beryllium is a metal, therefore it is going to lose those 2 electrons so that it has a full first energy level. The fluorine atoms need how many each? Need 1 each. So what is our best solution here? We're going to make 1 compound. We know it's BeF2. What do you think, Jet?
You put
good. He said you put one of each of the beryllium electrons to the fluorine atoms. And that's absolutely correct. Beryllium wouldn't just give up one electron, because then it would not have a full outer energy level. It has to get rid of all of them. Okay? So we'll send one of them to this fluorine atom, and we'll send the other valence electron to the second fluorine atom. Now, is the beryllium now stable? Yes. What is its oxidation number? 2 positive. It lost 2 negative pieces, taking on a positive charge. And our fluorine, let's look at this fluorine. Is it stable? Yes, it now has 8. What is its oxidation number?
2 negative.
Let's do them one at a time. Good. 1 negative. And this one? 1 negative. So as a total compound, though, we've got 2 minus 1 minus 1, which is 0. So our entire compound is indeed neutral. So let's fill out our chart. We have beryllium and fluorine. Beryllium with 2 valence electrons. Fluorine has how many valence electrons? Okay, let's say 7 each. Let's see, who have I not called on? Cameron, what's going to happen with our electron transfer with beryllium?
It's gonna lose 2.
Lose 2. And how about with fluorine? Catherine, what about fluorine? You could say gains 1 electron each, or gains 2 electrons total. Either one would be fine. Gains 1 each, or gains 2 total. Right? And then lastly, our ions formed. We have Be, 2 positive. And don't forget, this is not just 1F, but F2, and I should have written that over here. We have 2 fluorine atoms, so we're going to include our subscript. We have F2, and our oxidation number is 2 minus. Good. Yes?